First thing, like I said, we're going to talk a little bit about some vocabulary associated with kites, and there's not too much that you have to worry about. Remember that the definition of a kite is that those two sides are congruent to each other, and these two sides are congruent to each other. So we have congruent consecutive sides, okay? Then the only thing you need to know is that these angles right here, right there and right there, the long ones are called vertex angles. So the two angles on either end are called vertex angles. And then, this is a little bit confusing, so make sure you're paying attention. The other two angles here and right here, don't freak out after I write this down. I'll spend some time explaining it to you in a minute. These are called non-vertex angles. Okay? It's a little sarcasm there. These are vertex angles. Obviously, then the other ones are non-vertex angles, right? Okay, little joke there, little funny joke. Thanks. Brighten your geometry day just a little bit. All right, so we are going to discover today, I believe, 4 properties related to both kites, the vertex angles, the non-vertex angles, and their diagonals. And so what I have here on the board is a kite, and I am going to draw in those diagonals. And I want you to look at the kite that I have there and make a guess about the diagonals, the angles, the sides, something fun that you think might be true. Yes?
Where they like intersect or something.
Where they like intersect. Where what like intersects?
That right there.
That right there, the two diagonals. Okay, so he's thinking that maybe where they intersect right here, the diagonals, they're perpendicular. And so let's see if he's right. So I'm going to measure this angle right there. And what do you know? That angle is in fact 90 degrees. And if I shift this around and make it a kite of well, that doesn't do much. Make it a kite of a different shape or whatever, you can see that the measure of that angle does not change. Okay? I haven't proven anything, but we're just going to go with what appears to be true. And so we're going to go with right here, the diagonals of a kite are the second one. The diagonals of a kite are what? Perpendicular is the word that we're looking for there. Okay? So first of 4 discoveries is that the diagonals of a kite are perpendicular. Let's take a look at our diagram again and see if we can figure something else out. Yes? Okay, McGuire is saying he thinks that the vertex angles of this... Okay, McGuire is tricking me into believing something that's not true. Jacob?
Line segment CB and B, like...
Oh, you want me to, let's get some labels here. Okay, what do you have?
So CB and CB or BD are congruent.
CB and BD are congruent. Okay, so he is saying that this distance right here is going to be the same as this distance right there. Can I get a drum roll? Oh, clicked on the wrong thing. Ta-da! He's correct. All right. So this thing is congruent to that. So let's find that conjecture. Okay, the diagonal connecting the vertex angles of a kite is the, what's the fancy word for when it cuts it in half? Bisector. of the other diagonal. Okay? Oh, you probably want time to write that down. Okay, so we got 2 of the 4. I'm not calling on you because you tricked me last time. Yes.
The non-vertex angles are congruent.
The non-vertex angles what?
Are congruent.
Okay, so he's saying the non-vertex angles are congruent. So he wants this angle right here. So we're going to measure that. Okay, we're not going to measure that. Try that again. He wants this angle right here to be congruent to this angle right here. Should we go drum roll?
No.
No? All right, let's do it. Okay, and yes, he is correct. So McGuire had it backwards, and that's understandable. A lot of times students think that this angle right here is congruent to this one right there, but they're not. You can kind of see that if you look at it. Angle CED is a lot skinnier than angle CAB, but these two are congruent to each other. And so that is the third one. That is this guy right here. The non-vertex angles of a kite are congruent. Anybody got the last thing? Any ideas?
Put it up again.
AB is equal to
AB is not necessarily equal to B to AC or BC or whatever you said.
I mean, AD is equal to AC.
AD is equal to AC, yeah, but that comes from the definition of the kite, so we knew that already. What the last one involves is this angle right here. Yeah, CEB is congruent to what? Very nice. It's congruent to this angle right here. And the same thing is true on the other side. These two angles are congruent to each other as well. Okay? And so what that means is since those two angles are congruent, that means this diagonal bisects these vertex angles. Okay? So the kite angle bisector conjecture is that the vertex angles of a kite are bisected by a diagonal. All right, same game now with a trapezoid. So a trapezoid has some different things going on with it. These guys, these sides right here that are parallel to each other are called the bases. Okay? And not surprisingly, hopefully, these things are called base angles. So those are a pair of base angles, and the ones on top are a pair of base angles also. Okay? And it's important to understand that you could have a trapezoid sideways, and those would still be the bases, or you could have a trapezoid upside down, and those would still be the bases. Yeah. So it's always the sides that are parallel to each other are the bases, even if it's resting on a different side. And then the angles that are connected to a base are, of course, called the base angles. This angle right here and this angle right here are consecutive angles. It says the consecutive angles between the bases of a trapezoid are what? What's true about those two angles?
Perpendicular.
Nope. Nice try, though. At least you participated.
They're congruent.
These two sides are parallel, so what's going to be true about those two angles?
Alternate interior.
No, they're same side interiors.
They're
Supplementary, right.
There you go. I was trying to spit it out. I couldn't get it.
Yeah, that's great.
Trying to stay away.
All right, then we're going to tack something onto this. This time we're talking in particular about an isosceles trapezoid. And an isosceles trapezoid, just like an isosceles triangle, is a trapezoid with two congruent sides. And if you change it to have an isosceles trapezoid, what do you think is true about the base angles?
They're the same.
They're the same, are the same. Or for fancy math people, we would call that congruent. Okay? The base angles of an isosceles trapezoid, only if it's an isosceles trapezoid. Okay, then the last one. What do you think is true about the diagonals of an isosceles triangle? Yeah, sorry. What do you think is true about the diagonals of an isosceles trapezoid?
They're
not perpendicular.
They're the other
They
thing.
meet in the middle.
No, they don't meet. They don't bisect each other because that would be somewhere over here. They're what? Yeah, they're also
Yeah, that
congruent.
too.
That's what I said.
No, I think he said perpendicular.
Oh, I did. It's the only word I know.
Is it an option for me to keep it out? I didn't know that.